Okay, so my name is John Nyman. Um, I've been doing F sharp, exploring it a little bit, and then getting more and more into it for about 7 years now. Um, and it's my favorite language so far. Um, so, um, let's see. So, oh yeah. Also, I'm recently unemployed, so if anyone knows about any positions available, I'm a .NET full stack developer. So, let's see. So, um, a lot of the introduction part will be from F Sharp for Fun and Profit. It's probably the most well-known F Sharp website out there. It's done by a guy over in England. His name is Scott Washlin, if I said that right. Um, and let's see. So, just a little background about F Sharp. It's been around for about 12 years now. Um, Don Syme, he was the originator of it, and it's based on uh, he it's basically based on OCaml, and it's functional first language, so it can do object oriented also. So of course you got the C sharp background. It interacts really well with C sharp, and um, um, so let's see. And OCaml, it can um, it could actually compile OCaml code into F sharp into the uh, this yeah. Um, okay, we got to make fun of functional programmers a little there. So, and it is true. As the hardcore functional programmers definitely can see the own reward in just the functional programming concepts. Um, so why should we use F sharp? Um, it's concise. There's it's really convenient. The correctness, concurrency, and completeness are some of the major reasons why F sharp is so nice. So F sharp is not a cluttered language. You don't have this. It's a white space language, so you don't have the spurious curly brackets and the semicolons at the end of each line. Um, there's no need to specify the type of object because it has type inference. Um, so sometimes you do because the compiler can't figure everything out, but for the most part, it can figure out quite a bit of it. So you almost feel like you're writing in a scripting language like JavaScript, except you actually have your static typing and your strong typing. Um, and then to solve a similar problem in C Sharp, a lot of times you'll see a great reduction in the number of lines of codes. That, and um, I at U-Haul, I trained a guy doing F sharp, a junior, and he says that it's definitely easier to read F sharp code. It does take a little bit of getting used to, but once you get used to it, it's you look at C sharp and you're just like, man, that's hard to read. So convenient. Many of the tasks in F sharp are definitely simpler to implement, like dependency injection or mocking. Um, Complex type definitions are simple. A lot of times, sometimes you have, it could be this or that. And so with union types, uh, it's much easier, which C sharp has it in C sharp 7, I believe. Um, but in F sharp, they're more powerful than that. list processing is easier, comparison equality, state machines, and type providers make talking to the outside world much, much easier. So the correctness has a powerful type system. The business logic can be typed right into the code, so errors are caught at compile time. And in my other talk today, I'll be going into more of that in depth in the making impossible states impossible. And has units of measure. So if you're doing gaming, a lot of times you need that units of measure, or if you're F# big in the finance world, and having that units of measure can be a big deal in the finance world. It's really easy to do asynchronous coding, parallelism, message queuing, event handling, reactive programming. Async await came from the F# world. And let's see, so, and mutability by default, so you don't need to worry about locks so much, or at all unless you're doing mutable. And completeness, like I was saying before, you can do OO code in F#. Typically, if you do want to do full-blown OO code, you want to reach for C#, because they do interact really well with each other. But sometimes it's really nice to have the method overloading that you could do in C#, and so you could just roll your OO code in F# and do that. And it's great for scripting. It has a F# interactive built right in. I don't know if you've used C# interactive, or I've never used it, but LinkPad, I don't know if you guys have used that. I imagine it's pretty similar to the F# interactive. So you could write your own scripting file, FSX, and it will be doing a lot of that, and you can see it working. And since everything's pretty much a function in F#, it's really easy to test. One of the biggest features that I love about F#, there's only a couple languages that have this type provider. So it originated from F#, and I believe Idris might be the other language that has implemented it. And in my mind, it's not a modern language unless it has type providers. And type providers basically create your types on the fly. So if you have like a JSON endpoint that you're hitting, and you could call that with your F# code, you could call that endpoint, and if that endpoint changes, it'll automatically update your code when you open up your file. It'll check that endpoint and change your types on the fly. So it's not, you don't have to remember, oh, I need to update that because it's changed. It just does it on the fly every time you open your files. So it's great for exploratory code. It eliminates barriers for working with diverse information. So yeah, just all those different points. And that last point, groups of types are only expanded on demand. If you don't use it, it's not going to show up in your code. And so let's go ahead and get into some code. That's what we're all here for today, right? Oops. If I can. There we go. Let me go ahead and actually mirror my device so it's easier to look at. Duplicate, there we go. And yeah, here, just a sec. Oh yeah, you're right. Okay, so resolution. You guys know how to change the resolution on one of these, Windows 10?
Yeah.
Right. Okay. So rare I have to do that. I always forget how to do it. Okay.
You can do Windows display too.
Okay. So do that. That looks a little nicer, huh? I gotta mirror it again. No, that ruins it. Okay. Okay, I'll just have to look over there then. Oops. Okay, so we'll actually change this to go to the bottom.
So it's interpreted and compiled?
So it has type inference, so it kind of guesses what your type is going to be. Well, it does a smart guess, and if it can't figure it out, then you have to set your own types. So let's see. So like here you have 5, and it will know that it's an integer because you didn't put a 0.0 after it or anything like that. So it's not going down for me. Yeah, I guess not. Okay, and it looks like that's big enough, so I don't need to drop into that. So this is a single line comment right there. And a multi-line comment is done with parentheses instead of a slash star. I'm not sure why that decision was made to do it that way. So in F#, typically we, instead of calling it a variable, we call it a value, because once you set it, it's that same value forever. Because everything's immutable, right? So there we go. This is my last slide, but my slide was moved over. So, okay. We'll just do it this way. No, well, Okay, we'll just skip that last comic. So let's see. So when I highlight this and do Alt Enter, it'll throw it into my F# interactive down there, and you can see the value. So you can see it's an int 5. You go to here, and it has that dot whatever, so it's a float. So we could do this one, the 5 with it. And you can see I made it a float by adding the dot after. Those values are stored down there, and here's a string, so I could infer that it's a string. So here's a list, and notice that it uses semicolons instead of commas, and there's a reason behind that madness. We'll get into that in a little bit. So we have that, so this is a list, and it's a linked list, right? And so a lot of times in functional programming, you use linked lists are easier to use with different patterns that you do in functional programming. And we'll get into some of that later.
Can you mix types in that? If I turn one of those into a float, does the whole list become floats? Or
you'd have to make sure every single one was a float.
so if I had a string there and I tried to make a float, it would be a color.
Yeah, everything has to be the same type. But there's a way around that. We'll see that in a little bit. In some languages, you call this a cons operator. And so basically, what you're doing is you're prepending the 1 to your previous list, but it's a new list, right? But since it's a linked list, it's not actually recreating the whole list, right? It's just creating a new pointer. And you could see here, let's see, 2, 2, 5. And you need the double semicolon when you're actually typing in the down there. But you can see, that still has its same value. And then if you want to append two lists together, that'll do that right there with the @ symbol. You don't always have to do that. You could do this instead. Now I'm going to do this with the single quotation there, the apostrophe. But in practice, typically you don't want to do that. But it's pretty standard among whitespace, like Haskell, F#, you could do that. So you could do append. So what I'm doing there is it's just creating a new variable, so it's just a new value. So it's just they allow you to, yeah, it's a character you're allowed to use in values. So you can see here that I can do it that way too, and if you find that to be more explicit, I typically use the append and don't use the @ symbol. But in some circumstances it might be useful to use the @ symbol. Okay, we already went over that point. Let's see. So the let keyword also does the functions. So here we have a function, and you can see there's no parentheses there. And that's done for a very good reason. And so we'll go into that a little bit later too. So here we have square. Now we could run that. So here's the type signature right there. So you have this, the name, and it's passing in an integer, and it's returning an integer. So that's just saying it's returning that right there, right? So you can see it's all inferred. And let's say, I wanted that to be a float instead. You could add the type in there to specify that, hey, I really didn't want that to be an integer, I wanted it to be a float. And yeah, you can see that caused the error right here. So I'd have to throw in the dot to make it work. And then here we have two variables. You notice that I didn't do a parentheses with a comma in there. It's still just spaced out. And then when you call it, there's no parentheses in there, you're just adding each one to it. There we go, got our 5. So, okay. So it's white space language, so when you do multi-line, all you're doing is just adding some spaces. You don't want to be using tabs in white space languages, you want to be using spaces. So let's see here. So, and you notice here that the equality symbol right there, oops, is just an equals. It's not a double equals. So it's kind of like SQL, right? Where you're just doing it simple equals. And here we're defining a nested function, just like I believe C# 7 can do, right? And then we're filtering this list, and let's see what we get. So send it out, and there we go, 2 and 4. Okay. And so you could use parentheses to clarify the precedence. So like we want to get the sum of squares, so we want to say, okay, we want to square it first, right? So we want to square each one, so we're mapping over it. And so map is similar to like select in LINQ. Are you guys familiar with that? So in functional languages like JavaScript, Pascal, and a lot of other ones, map is typically the vocabulary you'd use for that. And so it's going to do a square on each one of those, 1 to 100, and then sum it. And apparently that number is, well, you guys can see it. So, okay. But that's kind of unclear, especially if you end up doing a lot of nesting. So we could actually do a pipe, kind of like you do in the Linux shell, or a command line in general, right? Where you just have your pipe. But in here, we're adding a little brace in there to just kind of look like a little pointer, right? So to make it even more clear, let's bring that all down. So we have our list of 1 to 100. Oops. And then we're going to square it, and then we'll sum it. You can see how we're talking about list processing. This is what makes it so nice, is you could say, okay, I need to do this first, and then I need to do that, and then I need to do that. And it's really easy to read. And then here we have a lambda. So instead of defining the function ahead of time, we have that lambda. So you just you write the keyword fun, and then you have your arrow between it and your variable or your parameter, and you get the same answer. Woo! And you guys have probably noticed we're not ever writing out return. Because it does type inference. In order to do that, everything becomes an expression rather than statements, and so and that's what makes it so it could infer the different types. Yeah, so here's our supercharged case switch statement. Just had a thought. So does that get me? Oh, no, that's not what I wanted. That's not what I wanted. Sorry, guys. Okay, so let's see. Yeah, I was thinking maybe I could push F11 to get it full size and get rid of all that up there, but yeah, that's enough space, I guess. So here's a simple pattern match. So you do a match with X, which is a string. Say if it's a A, then print A, and if it's a B. So you probably guys, anyone familiar with the C languages are probably familiar with that printf. And
switch on types? You can't do that in C# would be nice.
you actually can. Well, yeah. So you can switch on types. You can create unions of types, and I think that's the next thing that we're getting into. So let's see. So yeah, so if it's A, it's B, but let's go ahead and comment that out. And you can see it gives us a little warning there. And it says incomplete pattern match. You know, it could be something else and you didn't figure that out. So it gives you warnings, and I think you could actually go in and change your settings and make it give you errors. So you always have to do everything else. And since it's a string, you know, there's an infinite amount of different values it could be. So we use that underscore to say it could be anything. We don't care. Yeah. And you could even give it a variable name, like let's say X, and then you'd be able to use that in here. Let's say you could say you know, %s, so it's going to be a string. So this is strongly typed right there, and then it'll print out what that string was too, right? Oops. We'll send that there, and X is A. Woo! Okay. Okay, so F# you can do nulls. is pretty much frowned upon. You could have, if you're talking to the outside world and it's null, you need to definitely check your types and make sure everything is what it is. But let's see. So, but instead of doing nulls, what we do is options. Now, option is wrapped in either a sum or a none. So if it's sum, then you put the value in there, and if it's none, you just write none. So you can see here, so it's an int option, and it's sum. So it's basically like doing a nullable with a type signature in it, right? But in C#, you can't do that for everything except in C#8, which isn't out yet. And then you can see here it has a apostrophe A, and that means that it's a generic, right? Because we don't have any way of knowing what that none refers to. So
So
just
it's not a unit, or is it just a generic?
generic. So it's like putting like the capital T in your function. Oops. So here we're going to match against the sum and none. So let's see. So this function will take an input, and if it's sum, it'll print out this. If it's none, it'll just say the input is missing. And you can see here, like I was saying before, it always returns something. And so here it's returning a unit, which you can kind of think of like as undefined or something maybe in JavaScript. And then let's go ahead and, so if we pass in the valid value that we defined before, you can say input is an int 99. And here, the input is missing. Yeah. Tuples in F# are basically anonymous types. And when you're doing that that kind of flow way of working with lists that we were looking at before, where you're just piping from one to another, tuples become really, really handy, and it makes it easy to work with. But if you do too many of them, you want to take a step back and create a record instead, an object. And it's C# is eventually going to get this syntax, so it's easier to work with too. So there we go. That's the type signature, has a little star between it. So int, and of course, and then here's a 3 tuple. So instead of having a list that with different types, so this was a question from before, right? You use a tuple instead. And so you can see string and boolean. And then here's our record types defined. And you could actually go like this. And then you don't need to have that semicolon in between, and it's a little nicer. You'll see different people do it different ways. So like you'll see people write it like that sometimes, or I think the official way you're supposed to do it is like this.
What does Visual Studio do if you do it like a Control KD format? Does it do with the...
Let's find out. Control KD. Whoops, what just happened?
Format the whole document.
Oh.
Whoops. Control Z.
Yeah. So if I highlight it, it's supposed to do it, right? No.
No, I think the keyboard shortcut. It's in the edit menu.
Okay.
Sorry. Shut up.
So
It's in format.
formatting. Is that
Yeah, advanced in format.
okay?
Format selection. Control K, Control S.
So yeah, just left it alone, huh?
Yeah.
Okay. Okay. So yeah. And so to define it, you just put the value. You set the values equal to each other in there. And you have to define everything at once. So if I leave that out, it'll give me an error saying, hey, I don't know what you're talking about. Sometimes you might, in a very rare cases, you might have two type signatures that are the same, and I believe it picks the last type signature. So if you have like a person and then person A, like and they both have first name, last name, and nothing else, I believe it'll pick person A instead of person as the type. And so what you need to do is you could just type in person, and then it'll say okay. Okay. There we go. We got our type. So union types. So this is whoever was asking about being able to pattern match on different types here. Here we're creating a type degrees C and degrees F. And we could say, make that of an int. And then, those are two different types, right? And a simple union type would be, you just leave it off. And let's see. And a union type, so record is kind of like saying this type must have this and that and that and that, right? So it must have first name and it must have a last name. A union type must have degrees C or degrees F. So this makes it a really, really easy way to figure out to have to OR your different types, right? So like in object-oriented language, you have to do these like, I don't even know how to do it. You have to like have like a visitor pattern or something. Is that what you have to do? You guys know? And then you have to have some like inheritance and maybe some yeah, I don't even know. It's just such a pain to do in an object-oriented language. But to model the real life, a lot of times you just need an OR, and C# is getting that too. Not as nice as F#'s union types, because it can't pattern match quite as nicely.
So it's like a struct with types.
Well, it's like an object. It's not necessarily a true struct. Yeah. Yeah. Well, yeah. So like here, I don't.
Because what it's doing is it's saying you basically having an artificial type called temp, which could be a degree C or it could be a degree F.
Mm-hmm.
So that's kind of like working TypeScript.
Yeah.
If you're coming from TypeScript, it is a
Yeah.
union type.
Yeah. So here we could see, we say it's a degrees F. There we go. It's a degrees F. So, and then you could have union types that are more complex. So we could have an employee that's a worker and a manager. And so we say we have JDo. We're going to make JDo a worker. There we go. Let's see. And so you guys, we kind of went into this a little bit before. Your strings. So this is the printf is like the console.write and write line. So if you put the f in, that means write line. All the types are statically typed in there. So the %s would be a string, %i an integer. The a is a generic type, and all the types have built-in pretty. So you can see here, it's a pretty pretty printing. And so you can see here when that prints out two tuple, you know, it's all nice looking. If you did like a O, whoop, capital O, you can see that's kind of the ugly printing. So if you just need to return a string and do some do it like the printf, you just use sprint and sprintfn. And it's similar to your string.format. So let's see. I'm not sure why I included this, but we can go over it real quick. So reduce would be similar to links aggregate, right? And so yeah, so we have that. Now let's go into JSON. Okay. So these are the type providers that I was talking about. And so this is a library that you, fsharp.data is a library that you bring in from NuGet. And let's see. So in here, I'm using a triple quote, which just says take everything literally inside it. And so you can see I have a JSON string in there, right? So let's do this. And simple JSON has a type now. That type is made up on the fly. So you could actually point this to a URL, but that URL can't have, what's the word? If you have to put in a username password for that URL authentication, then it won't work. It has to be something it can just call. As far as I know, unless they've changed something. So then I can get the sample. So the sample is just, so I could throw in another string and have it different than this one, but doing just get sample is just kind of nice for working with. And then do says just do this stuff. And you know, things that return unit. That's probably not a very good explanation, but we'll just leave it there. And there we go. So we had this JSON, we turned it into a type. Then we were able to take that type and give it to us. So you can see like it has lowercase a, it capitalized it. You can see it gives me all those different types. Um,
For the JSON, like it didn't have, let's say if you have
okay, so let's see. So we're using D. Now it gives me an error. D's not defined.
oh, okay, so it's doing, is that a runtime error? Or is that a?
No, it's as I'm typing, right? So
Like, you're saying like the IDE is reflecting the JSON literal right there? Like the combiner is
Yeah.
literally running code to provide higher information to that run. It can be done like a database.
Yeah.
Oh, that's crazy.
That's like reflection, right?
Yeah, absolutely. Yeah,
yeah,
yeah. Yeah, it looks like piece of JSON is detailed here. And now it's structured.
yeah, yeah. So it's all live. Yeah.
I'm assuming you don't get that, I'm assuming you don't get that kind of hand holding if you're pulling off the server someplace.
Yes, you do.
Wow.
Yeah.
Yeah, I guess the problem comes up when you expect the D field and it's changed and it doesn't have it.
Right, yeah.
Yeah,
What
and that-
what I'm actually wondering is, like, if I had a server and it gives me ABCD the first time, and this thing reflects the code out and says, hey, this is ABCD, and then the next request, for whatever reason, the person removed, the developer decided to remove the D field from the JSON, and some other request, like, does it handle that well, or does it just go, that's not gonna work?
Yeah, it says it's not going to work. So
So they expect consistency.
yeah. Yeah, so it'll say, hey, you're supposed to have that, it's not there. So then you yell at the other developer, and or you speak nicely to them, say, please put that back in, or you just change your code to reflect. I mean, if that's like a new version, you just change your code to reflect the new version. So we'll go into SQL. This is probably what I use it for most. Well, I use it for JSON and for this most. And you could do it, there's type providers for all sorts of things. There's for CSV files, there's type providers for HTML pages. For static pages, it doesn't do, if you got everything going crazy in there with JavaScript, it's not going to work for you. But yeah, there's type providers for all sorts of things. There's type providers for yeah, for XML. It'll create all your types for it. But we're just going to go into SQL. So fsharp.data.sql client, I believe, was created by some guys from jet.com. I don't know if you guys are familiar with that. Walmart purchased them not too long ago. They were trying to create a kind of a competition against Amazon, yeah. And I believe most of their stack is F#. It's all F#. Okay. Yeah, and so they're pretty hardcore F#ers. So not your grandfather's ARM. This is way better. Oh, and same. So the connection string here, this connection string is like a literal is like saying a constant in C#. And it's saying there's something not right. So let me see if it's on my box. So let's see. Maybe it's not on.
Do you get any more info on the text over?
Yeah. Yeah, it'll. Yeah, so network related. And that's because my SQL server is not on. So I'll go ahead and start it real quick. This is the last example, so it looks like we're ending just about right on time. And there we go. It started. So we'll go ahead and close this file and then reopen it. You can see it kind of hiccup there a little bit, so that means it's probably talked to my server. There we go. And so here I'm just calling a stored procedure, but you could actually write code. You could write your SQL in one of my other presentations, the scripting in F#. I actually have an example of writing SQL code in here with all these types, and it'll tell you if you put something in wrong, because it sends that snippet of code to SQL Server, and it has SQL Server tell it what the types are, and it sends it back, and then it'll give you all the types. So here you can see so it gives me all those different variables that come back from the SQL statement and the stored procedure that it sent, right? So let's go ahead and run it. So this works for SQL Server 2012 and above, because SQL Server 2012 and above is what is able to figure out all the different types for you, right? And I'm actually giving another presentation today on SQL Server Data Tools that kind of goes into some of that a little bit, that uses that capabilities. Yeah, so yeah, here we go. So it gave us back that list of names there. Yeah, this one only works with SQL Server. There are other ORMs that work with Postgres and things like that. I forget what their names are, but I'm always working with SQL Server, so it's pretty convenient. And you could actually, if you have like sometimes you're working with stuff from before SQL Server 2012, right? But if you have SQL 2012 and above on your own machine, and you have that database mirrored on your machine, you could actually have it hit, because the connection, you could connect to anything you want after this. But if you connect to your local machine, and then like let's say you have SQL Server 2008 that you're actually working with, that the code works with when it's live, this will still work, because it's figuring out the types from your own machine, or from 2012, or if you're pointing to like maybe a staged machine that's 2012 and above, it could work. It could backport to ones before then.
So in other words, 2012 has type inference features that it needs.
Yeah.
The older ones don't provide that.
Right.
And now, if you're stuck in an old one, does it fall in its face, or can you just limp along and, look up the field that is old-fashioned way?
Yeah, you wouldn't be able to use this ORM. You'd have to use maybe a different one, or just go back to ADO or something, or
Okay.
so. Cool. Any other questions?
Yeah, just real quick. So say I wanted to have my ORM in F#, and I want to consume it in C#. You just compile this F# deal. What does it look like when you call it from C#?
So if you did that, it wouldn't work, because you have to actually use the code, otherwise it won't create the code. What you'd have to do is you'd have to write out the actual type that you want to use. So you'd have to create a type here, and so you'd have to go like type employee person info. So you'd have to create that type and then map it to that type, so it knows that you actually used it, and then you'd call it from C#.
You're building a library, but at the end, this would be the DLL.
Yeah. So, and then you'd have to This one's built specifically, this ORM's built specifically for F Sharp, so it does use the option type. So it'll tell you, oh, this column might be missing, so it could be some or none. And then, the whole thing might be missing, so, you have to do a pattern match on that also. So, yeah, so
So you think it's like kind of translate, like I had a function in here that was doing the DB call, and in C# when I want to call that thing, F# has to be taught more stuff in order to.
yeah, basically you'd have to write it so C# can interact with, yeah, exactly. Yeah, and yeah, well, yes, pretty much. And the interop, making C# and F# interop together well. That F# for Fun and Profit website, he has a whole blog post on that, and his blog posts go in super in depth. So if you guys are interested, I could look it up and post it on the notes afterwards.